Welcome. Today we're going to be discussing speed and velocity. What you're going to learn is how to calculate slope from ordered pairs and from data collected from a graph and interpret the data given from a distance time graph. Okay, right here what we really want to work on then is finding the slope. And this is the equation you were given algebra. So it's nothing new there for you. It's the same thing you guys learned in Algebra 1. What we're going to do with it then is we're going to go ahead and use it with some ordered pairs. Well, what I advise you to do whenever given these ordered pairs is to label them. The first set, call them x1, y1. The second set, x2, y2. And then we're simply going to use what the equation tells us. y2 is 7. y1 is 1. And then x2 is 4. And x1 is 2. Well, 7 minus 1 is 6. 4 minus 2 is 2. So my slope is 3. Same thing here, x1, y1, x2, y2. So it becomes negative 2 minus y1, which is 7, over 4 minus negative 3. I'm going to go ahead and hit that, do a little negatives, and we get negative 9 over 7. So there's our slope. Well, then let's look. Slope some graphs. In a distance time graph, which is what we've been dealing with here, distance and time and speed, distance is going to be on the y-axis, time is going to be on the x-axis, and slope is the speed. The reason that is because if you think of slope, slope is defined as the change in the y, or the rise, and on the x and y-axis, the y would be the rise or the dropping, over the change in x, which is the run. That's why we say it's the rise over the run. Well, the x is the run. Well, on a distance time graph, distance is the y-axis and time is on the x-axis. So distance is here, time is here, and what is distance over time? It's speed. So the slope of a distance time graph is speed. Okay, well, in algebra you're taught y equals mx plus b. What I'm going to quickly point out to you is our equations we've been using, d equals rt or d equals vt, which is probably closer to what we've been using most often, d equals vt. The d is in the place of the y, so that's why the distance is on the y-axis. The v is in the place of the slope. That's why the velocity or the speed is the slope. And t, that's in the place of, not t, sorry, x. X is in the place of the t, so that's why time is on the x-axis. Well, as you can see here now, we've got distance over here on the y-axis, just like we said. We've got time down here on the x-axis, just like we said. And what we find out here is the speed is the slope. So what is the average speed of this object? Well, we've got these instantaneous speeds here, and that's the green line. But we have this average slope. This is the trend line that we worked on the other day, that we put in there. And what we find out then, this equation, this is d equals v times t. And I could care less about this last part right here. So distance is on the y-axis. The velocity, which is actually the average velocity, and t is in the place of the x. That's down here on the x-axis, the time. So my average velocity is 0.2857 meters per second. I'm not really worried about number 2. We don't care about that. What is the instantaneous velocity of the object between 5 and 6 seconds? Well, what they're asking us here then is we're going to look at the green line. Whenever they use the word instantaneous, that's going to be these lines. Whenever they use average, that's going to be the trend. Average, so I'm going to use the trend line. Instantaneous tells us we're going to use the actual. Well, to find that, I'm going to write down these ordered pairs and just simply find the slope. I'm guessing that one to be about 5, 1.4. And then this one right here is about 6, 1.6. x1, y1, x2, y2. So my slope, or the instantaneous velocity, is going to be 1.6 minus 1.4 over 6 minus 5. That gives me 0.2 over 1, which equals 0.2 meters per second. 0.2 meters per second. So, right here, its instantaneous velocity is 0.2 meters per second, which makes sense because the slope here is smaller than the average speed. So it ought to be slower than the average speed, and it is. This one has a greater slope, so if I were to calculate it, I bet it's greater than 0.2857. Okay, here's what I want you to find on your notes. I want you to find the acceleration. Actually, I want you to find the speed. I typed that wrong. I want you to find the speed between 1 and 2 seconds. I'm sorry, I'm going to change that. I want you to find the speed between 2 and 4 seconds. I want you to find the speed between 4 and 6 seconds. And then I want you to find the speed between 6 and 8 seconds. So you got 3 of these to find. Total of 3 of them to find. Hey, I'll catch you on the flip side.